Well, what we do at Cospas-Sarsat is we look at the needs of those in distress. We look at the needs of those who search for those in distress. We find the technical expertise to make that happen. The operators, who are very familiar with what it is like to find distressed people, are very good at describing their needs. The engineering side of the program are very good at interpreting those needs and developing hardware and a system that can do that. Put all that together and you have user to search and rescue authorities in one push of a button.
Cospas-Sarsat a été initié durant la guerre froide en 1979 et a fait l'objet ensuite d'accords intergouvernementaux, en particulier celui de 1988. Depuis cette époque, le système a évolué, mais je dois dire que ce qui est particulièrement excitant et challenging dans le programme actuel, c'est que le programme est en train de vivre des évolutions très fortes, avec d'une part, par exemple, la transition du système à partir de l'utilisation de constellations de satellites en orbite basse et en orbite géostationnaire vers un système basé sur les constellations de satellites en orbite moyenne, ce qu'on appelle le MEOSAR.
The Cospas-Sarsat beacon is a radio-based transmitter. Technically, the way that it works is the user, which is actually going to be the victim that is in dire need of being saved, hits the button. There is an antenna that is hooked to the beacon itself. The antenna is the mechanism to allow transmittance of the signal. The signal itself gets beamed into space, where we have hardware, instruments, orbiting around space, waiting to actually pick up that signal.
Any distress beacon that's coded, they've been type approved through a set of rigorous standards that the Cospas-Sarsat program has established. Whatever country you're from, the global system will work with those beacons.
Each of the beacons is designed for the environment it's designed to work in. So EPIRBs are designed for use at sea, ELTs are designed for use on aircraft, and PLBs are for personal use by people in a range of different environments.
When the beacons go off, we start the ball rolling that it's distressed. We'll make phone calls to the person that the beacon has been registered to and then try to identify whether that person's actually in distress or not. Registration makes all the difference in us being able to quickly identify that there is actual distress out there. If we can't get an identification that they are in distress, we'll automatically assume distress and start responding with assets.
All of this information will help reduce the risk to the search and rescue services because they put their lives on the line every time they go out to try and help save people. Secondly, it should reduce their costs because they don't have to perhaps search as much. We're trying to take the search out of search and rescue. So the benefits overall are quite useful for the whole of the community.
Les satellites volent à une très haute altitude au-dessus de la Terre. Comparé à des systèmes de communication terrestre ou même aériens, un satellite voit donc une plus grande zone de la surface de la Terre. Pour détecter des balises, un satellite est également moins gêné par les obstacles alentours ou par la courbure de la Terre. De plus, un satellite n'est pas affecté par les océans ou les environnements difficiles, où le déploiement de systèmes de communication terrestre est compliqué et coûteux. Enfin, un satellite est la solution la plus efficace pour un système international offrant une couverture mondiale pour les utilisateurs en détresse qui peuvent se trouver dans des environnements très différents, par exemple à proximité d'une côte ou dans des régions montagneuses ou désertiques.
MEOSAR combines the advantages of the LEOSAR and the GEOSAR systems. The motion of the MEOSAR satellites relative to the Earth allows our system to use mathematical analysis of the signal to instantaneously compute the beacon's location. The altitude of the satellites mean that each can see a large portion of the Earth's surface. With MEOSAR, we're talking about 4 constellations carrying our search and rescue payloads aboard satellites of several cooperating governments. By the late 2020s and beyond, we could have as many as 96 MEOSAR satellites listening for 406 distress messages, an extremely robust space segment capability.
The main purpose for Cospas-Sarsat is to save human lives, which perfectly matches the core objective of BDS, benefiting the mankind. For the inclusion of Beidou navigation satellite system into the MEOSAR constellation, we are very honored and at the same time clearly aware of the responsibility we are carrying. BDS currently provides 6 search and rescue payloads. The inclusion of BDS into Cospas-Sarsat further complements the space segment and provides more available search and rescue payloads, therefore improves the success rate of search and rescue.
So with a typical MEOLED installation, you would have anywhere between 4 and 6 antennas. These, you can see them behind me right now. So currently you can see them tracking different satellites because they're at different angles. Most of them are picking up the GPS S-band satellites, which are in our view, in our area here in Ottawa. A couple of them are picking up Galileo right now. Later on they'll pick up a GLONASS when it's in view. And what they do is they take beacon signals coming in and locate them. Most systems around the world are currently 4 or 6 channel MEOLEDs, and as we progress and get more satellites in the sky, your 6 channel, 8 channel MEOLEDs will be really good to have, and you'll ensure your coverage area and picking up those beacons in distress when they're triggered and activated.
A mission control center is where the data from the local user terminals is geographically sorted, and it provides the distribution of the SARSAT alerts to the rescue coordination centers. Also, the Mission Control Center matches registration information with a hex ID to a beacon. So the relationship between an MCC and an RCC is a very valuable link, because the MCC feeds the information to the RCC, and the RCC is able to coordinate the search and rescue and get the individuals out of harm's way.
The search and rescue staff on duty will assess where it is, what it might likely be, and what's the best response, and they will then coordinate whatever is the best response for the time. That may be a helicopter if it's close by, it may be a ship if it's well out to sea. They'll work that out for each individual circumstance.
We don't like to go in unprepared, so knowing location, what kind of terrain they're in, what kind of equipment we're going to need to access the site is certainly important. And then when it comes down to the individuals on location, if we can get medical information early, then we can bring the proper medical equipment down to the site and make the whole thing a lot faster.
It's not just us in the command center, it's the controller who sent us a SARSAT message, it's the helicopter or the boat crew. The amount of coordination that goes into these rescues is amazing, and when everything aligns, first off, aligns by the end user, the person who purchases the beacon, who registers the beacon, who maintains the beacon, looking out for their own welfare. They're the first link in that chain. They activate it when they believe that they're in imminent danger and or distress, and it sets the whole SAR system in motion. To watch that whole system work and achieve its desired end state is amazing, and it's why we do it, and it's that moment that we prepare for.
Как и любая техническая система, она опирается на инновации. Развитие системы, развитие в наш бурный, как говорится, век, развитие инноваций и техническое совершенствование системы. Без этого невозможно представить будущее любой спутниковой системы, любой вообще техногенной, технологической системы. Поэтому инновации — это та самая отправная точка, относительно которой и считаются шаги в эволюции любого технического инструмента.
Cospas-Sarsat, along with other aspects of the international community, are looking at two main innovations going forward. One is the MEOSAR system, and within that second generation beacons. But then in addition to second generation beacons, there's triggered in-flight ELT-DT, specifically to try and address the issue of aircraft that crash in remote locations and can be difficult to find under those circumstances.
Ce qui m'impressionne le plus en Cospas-Sarsat, c'est ce système qui offre un service gratuit, sans discrimination et partout dans le monde. C'est un système unique dans son genre.
Cospas-Sarsat is a remarkable achievement of humankind. Since the program began in the early 1980s, more than 40,000 people have been rescued with the assistance of Cospas-Sarsat. On average, each day, there are 2 distress incidents where Cospas-Sarsat provides the distress alert information to government authorities. These 2 distress incidents, on average, include 6 people per day. Cospas-Sarsat aids in the rescue of 6 people every single day. In half of those distress incidents, Cospas-Sarsat provides the first alert to government authorities that someone is in trouble. In a quarter of those incidents, Cospas-Sarsat provides the only alert that someone is in trouble. Cospas-Sarsat saves lives.